Yeah.
Thanks for having me.
And let's move on to the last session of the conference between the closing. So the next speaker I would like to invite here is Alessandra Caputo, introducing a work entitled The Role of Open Data in Driving Innovation Insights from UniProt.
Yeah, thank you, and hopefully I'm going to be brief. I know we are over time already. So basically, what I'm going to present is part of a case study that we run within the Pathos project. So as Joanna already introduced you to the overall Pathos project, I will not dig into the details, but just remind you that among the 6 case studies, there was one on the Elixir, so on bioinformatics. And what we tried to do within this case study was, first of all, to reconstruct the entire impact pathway of the UniProt database, which is this open resource repository, and I will provide you a few additional details just in a moment. The idea of our impact pathways, of course, is that we start from some inputs to arrive at the end to the impacts. When it comes to the outcomes that you receive, you will have short-term outcomes, as it can be cost savings or labor savings, transaction savings. So all these type of outcomes are the ones that we captured through the CBA framework, so where we were able to basically compare the investment cost and the maintenance cost of such an infrastructure against the benefit that you will have for the final users. At the same time, having open data available does not only provide the possibility for users to save time, save money, and have already curated data, but also provides the possibility to innovate at a faster pace. So within this case study, we have then treated these innovation pathways that can arise from open data separately from the CBA, and this is due to the fact that this would be what we call long-term outcomes of the project. So within the context of the CBA, we could not include them to avoid double counting, because first you have the transaction saving and then you will arrive to the innovation. So in order to track the innovation, what we did was to search for publication and patent that were actually using the UniProt database. So the overall research question is, to what extent the open data made available by the UniProt repository are allowing for fostering innovation. So, and our key assumptions are, on the one hand, that the availability of this data would be helpful for the industry, that would be able to increase its patenting activity, given the fact that data are already there and they do not have to develop the database themselves. But on the other hand, there is also, among our main assumptions, the fact that the scientific community can use this data, leverage on the data available, and so start publishing more than in the absence of the UniProt database. So moving to the UniProt database, just few words on this. What I want to stress is that this is a completely free and accessible database, including data on proteins. As you can see from this graph, it's also an integrated database already, which integrates data coming from existing sources, which were SwissProt and Tremble. And we will see in a second the fact that they were already existing, but starting from 2001, they have been integrated together within this UniProt KB repository. And then you have additional sources such as UniPark, Proteomes, and UniRef. All these is all available online and can be downloadable in different ways, can be integrated through APIs, and so on and so forth. As I mentioned, the history of UniProt is long-standing, so the first data dates back to 1984, but only in 2001 we have that UniProt was formed as a consortium, integrating all these data available before together. So why I'm showing this, the roadmap of UniProt, is that having this in mind as also brought us to some decision in terms of the time horizon of our analysis, so understanding when to start searching from the usage of UniProt data. So what we did was basically, we can say, a keyword search. So as we said before today, searching for data citation it might be not so straightforward, given the fact that in most of the cases you miss the DOI citation or a formal reference within the publication. So we actually noticed this manually by seeing the fact that in most of the cases UniProt annotation were just mentioned in the text of the publication without the formal reference at the end. So this is the reason why we opted at the end to search for publication on the one hand that were mentioning the various UniProt repositories, so UniProt as such, but also its segments, so UniProt KB, UniPark, and so on and so forth, in the title and the abstract of the publication, focusing on the period 2003-2022, and this is because UniProt actually as such was launched in 2002, as we said from the root. On the other hand, when it comes to the patent analysis, we try to perform two types of analysis. So we call that a narrow approach, where we replicate actually the same search in title and abstract of patents over almost the same time period, but also we then extended this analysis to have a broader picture. So we do not focus starting from the UniProt creation, but we go back to 1988 when the first patent was actually retrieved, and we extend the search to the full text of patents. The data sources that we used were OpenAIRE for publication, the PATSA database when it comes to the search of title and abstract, whereas for the full text search of patent, we use the Orbis IP database. So we have a mix of data sources, it's true. Going to the results, starting from the publication analysis, what we see is that actually, starting from 2003, we have more than 6,500 publications that reference, or we can say mentioned, one of the UniProt sources in their title or abstract. And interestingly, the most cited source is UniProt as a whole. So I mean, is the overall repository. And this is followed then by SwissProt, which is actually a repository that was not more in place from 2003, but it reminds that basically researchers are used to talk about SwissProt instead of UniProt KB, which has then included the SwissProt repository. Moreover, we try to understand also where, what these publications are about. So looking at the field of science, we notice that basically they span over different fields of science, but given also the nature of the data that we are tracking, the vast majority relates to medical and health science, and in particular to developmental biology. Anyway, this is not so surprising given that we are talking about protein data. Another point that we tried to track with the publication analysis was to understand to what extent the publications that are making use of the UniProt data are also contributing to the SDG. And interestingly, we found that almost 31% of our publications are actually related to an SDG. And even in this case, among the SDG-related publication, we found that the vast majority is about good health and well-being, and a minor share to zero hunger. Moving to the patent analysis, what I want to say is that if we look at the narrow approach, just few numbers, we have 164 patent applications that belong to 78 distinct patent family. The entire analysis, and this I want to stress, was conducted at the level of the patent family to avoid a double counting then. And what we see is that these patents relates basically to biotechnology. Again, it's not such a surprise. What was interesting was then to understand the step forward in the knowledge creation, so understanding how many patents are citing the patent that made use of UniProt data. And in the graph that you see on the right side of the slide is actually the network of the citing patents. So the orange dots are our first tier patents, so those mentioning UniProt, whereas the blue dots are the ones that are then citing our patent. On the extended approach, the main results are actually unchanged, but for the numbers, we moved to over 44,000 patent families, but we have to bear in mind that here the time horizon is more extended, and so it's not only a difference in terms of the text that we use to search the patent, but it's also the fact that we started in 1988 to cut. And we have that, what was interesting also is that we try to understand when it comes to the citing patent, so the patent that cite our major patents, to what extent they are not only expanding the overall knowledge, because of course we are creating new knowledge, but also to what extent the fields where these patents are the field of the invention of these patents, whether this is broadening or not. And as you can see from here, we moved from a 95% of patents that were in the chemistry sector, but then they are going to be cited by more applied patents. So we moved from sort of fundamental research to more applied research. Of course, and I'm concluding, these are analyses that provide us with insights on the knowledge that UniProt database, so that open data repositories might create, but we are aware that we cannot draw any causal conclusion, of course. At the same time, I'm not presenting any results on that, but we complemented this analysis with a survey to the user of UniProt data, asking to what extent the research they were doing, thanks to those data, would have been available otherwise, and to what extent, thanks to the UniProt data, the publication and the patents that they have done would have been made, and which would have changed otherwise. The vast majority basically declared that they would not have been able to produce those patents, whereas for the publication, they were basically saying that they would have needed additional time. So indeed, there was a time savings that was leading to the publication they created. Overall, what we can conclude is that actually UniProt is really accelerating indeed scientific research and innovation, and is enabling this knowledge creation channel. What we have learned through this long journey has been that first of all, the keyword search strategy is affecting significantly, of course, our results. So, and a lot of manual validation was needed to ensure that we do not have false positive within our sample, even though actually the name seems to be weird and not to have not to give rise to false positive. I can tell that start from the tremble repository, you have the entire declination of the two tremble verbs, so it was kind of a mess. On top of this, again, just looking at the citation as such cannot lead you to draw any causal impact conclusion, but at the same time, you can complement it with survey results, etc., in order to provide, more conclusive conclusion. And I would say that I'm over time, so thank you.
Okay, any question from the audience? Tired, huh? I do have one, very quick one. Actually, I have a bunch of them, but just to, not to, you talk about in the studies that you have run about patent citations, about publication citations or mentions, whatever they are, to the various entities that are described in the database. This data is something that you have internally, or do you rely to external database for gathering patent citations from publication and these kind of things?
So for the publication mentioning UniProt, we relied on OpenAIRE, that was partner of the project. as well as for the Orbis IP. This is a license we have internally at CSIL, so it's not open, of course, and the same applies for PATSAT. So it's a mix of...
But you are entirely open as an approach instead, as a database. Okay,
yes.
got it.
Thank you. It's a techno-legal question. On which legal basis you were able to use TDM on patents?
Sorry?
On which legal claims you were able to TDM the patents?
What do you mean by TDM the patent?
I mean, to search for these things inside. Did you do it automatically?
You mean the retrieval from the database?
Yes.
It was an automated search, but then we extracted the text in order to revise it manually and ensure that the automated search was run correctly. And this is the reason why we understood the fact that despite these keywords, there were a lot of false positives that we have then to clean up by semi-automated approaches, because there was the manual revision and then the automation of the instances that we were observing as repetitive false positive.
Okay, but these texts, they are proprietary, they are under copyright, are they?
I mean, okay, I see what you mean. The point is that you can do that only once you have extracted the data, and the data originally are not open source. So we can share, of course, all the data cleaning procedures that we perform, but we cannot share the raw data that we extracted from PATSAT and Orbis IP at least.
Okay.
Last question. Okay, there are no more questions from the audience, so thank you, Alessandra, for your talk. And next talk is from Giulia Malaguarnera, and the title of the talk is Advancing Open Research Information, Insights from the National Open Access Irish Monitor.
Thank you for having me. So what I am going to present may answer to some of the questions that were asked yesterday. So how we can use the open research information for monitoring activities. And I will speak about this case of the Irish Monitor, which came inside a policy context. So it was launched in 2022, the National Action Plan for Open Research in Ireland, and it was a long-term action plan with the aim of having 1,000% open access, publicly funded, promotion of culture of openness and collaboration, and embedding fair principles inside the activities. So the questions from the Irish stakeholders was, okay, how we can monitor, how we can track what we are doing. This is why the mission and objectives came to have an open access monitoring tool that was serving as a crucial tool to analyzing the trend during the time, not for trend ranking activities. So it was more for decision-making activities and tracking the development of the research activities that was performed in Ireland. So what happened? The North launched this call for an open tender to have a monitor tool, and OpenAIRE was awarded to having this contract in July 2023. Then we launched the official monitor in March 2024 after a long discussion and engagement with the Irish stakeholders that were between the universities, the funders, organization, repository, and other institutions, and the researchers as well. And it was officially launched, this monitor, with several dashboards. And in last November, we had also the good news that they wanted to renew the contract with us till the end of this year. And hopefully, we will get an extension. So, how this Irish National Monitor is made. This is what you will see in the first page. So if you would like to scan the QR code, you will see the National Monitor. And it's made of these five dashboards. So you have the national umbrella, and then you have the research funding organizations breakdown, the breakdown for each university and the research performing organizations that are present in Ireland, the vision from the institutional repositories, and also you can see the contribution made by researchers by searching for ORCID. So at the end you have several dashboards in which you can have an indicator of visualization and filtering. You can also understand the trend over the time about what we are called or what we are measuring as openness score or fairness score in terms of data or publications. And you can also filter by funding or by collaboration activities or impact. You can also have the possibility to search each content that we are analyzing and performing as statistics. And you also have the possibility to zoom in on the research output. So you have a page in which all the metadata information are there, including the abstract, the metadata information about affiliation, authors, contributors, and so on. How we build it. So this monitor have as a data backbone the OpenAIRE Graph. And why the name of OpenAIRE Graph? This time I would like to dig a little bit on the concept of scientific knowledge graph. So usually when we are speaking about the database that are on the research, we are thinking about Web of Science, Scopus, all the proprietary database. But in the reality, there is a link between each metadata. And this is what OpenAIRE is forcing to do. This link functionality makes every metadata in a context. For example, there is a link between publication, data sets, also funding activities, and everything is related to ORCID and persons or research institutions and affiliations, projects, organization. So when we are speaking about a knowledge graph, it's much more complex than a simple database. We do this for research discovery, bibliometrics, evidence-based policy, and now we have also launched the API that make everything easier for bibliometricians to work on. So what were the challenges when we built the monitor for Ireland? Metadata inconsistency, this is something that you may expect. Incomplete records, variability in compliance across disciplines or across institutions, because every university may have different repositories or different servers or software they are using. And how we have addressed this issue. We worked together with all the stakeholders that were part of this monitor. So it's a community effort here. What we did that were the main issue were these metadata anomalies that could be errors from when you are actually adding inputs inside the repositories or inside archives. It was a lack of metadata curation or maybe different formats. that were coming when we were aggregating all the information from different sources. And also, we worked together with these stakeholders to identify the issues that were coming in the production workflow. What I mean for workflow, so basically the OpenAIRE Graph is built by several onboarded data resources that are using the OpenAIRE interoperability guidelines, in which basically we have a standards of metadata for everybody to make sure that we have the basic information for performing any kind of analysis or reaching the data. Then we are aggregating all this information also by taking other instrumental data sources. We are enriching with the full text by mining. We deduplicate the metadata information. We enrich by inference. And then everything that is finalized is appearing in the OpenAIRE Graph. And this is, by filtering from countries or from the different entities that I showed before when I was showing the knowledge graph, is how we built the national monitor. But we also asked some feedback, how we did that. We think with the ORC ID made by the researchers that were giving to us from the universities, we also allow people to link between the different entities. We also worked in a sandbox. We upload the DOI, we connect with the repositories from Ireland. We also use OpenORCs that was presented today, also thanks to Nice, and we curate the data and support. So what we have learned, and I am basically closing. So the lesson learned was that by doing this work in a much bigger framework, engaging each stakeholders to improve their own dashboard that were already open by default, there was much more engagement and interest in improving the data and the metadata information. It was clear the objectives, so why you have to improve the metadata, because then you can retrieve monitor and tracking activities, so there was much more interest on curating the metadata information. And then it was also to understand how the data were interpreted. So how they wanted to be, they wanted to report some kind of analytics or some kind of data, and everything that was around that. And then we have also support them during the time, and also doing a lot of sprints to do this extra curation together. So the Irish use case, it was a very nice experience, and it's still a great experience to work together with the community, because the fact that everything is public and the fact that you can find errors or some needs of curation make everything like we are working together for a bigger vision. So what is coming next is that we are going to improve some kind of functionality, and we are hoping that this work is continued. So thank you.
Okay, any question from the audience?
Just to be sure I understand your point. So you mean that there was no CRIS in Ireland before, no database on which you could do this kind of analysis, and that's why you went to OpenAIRE?
No, it's a little bit different. even OpenAIRE is also aggregating from CRIS system.
Yes, okay.
So what we are doing is that it doesn't matter which kind of software, for example, you are using for CRIS systems or for institutional repository. What we do is the aggregation. Of course, we are trying to get as much data as possible. Sometimes the CRIS systems have much more information and much more database that we are improving by the requirements that we are receiving. But having a national CRIS, it's costly. OpenAIRE is a non-profit organization, and we have a lot of experience between initiatives, projects, and we are aligning everything with Europe. So it makes also easier to expose the data, for example, in the European Open Science Cloud, or more globally because of the collaboration that we have. So their interest was to have everything that was transparent by default. And that was going beyond the technology that were present, for example, in a CRIS system.
Thank you.
Other questions? I have a quick one, but just because I'm curious, I have to confess. So this is an experiment that you have done with a country, which is Ireland. Are you planning to do some more experimentation with other countries, or at different levels, instead of just a country, a region, or even more as universities and these kind of things?
Yes, thanks for this question. So at the moment we are working on the national monitoring in Greece, and it's going to be a little bit different from the island, because the island was focusing on the publication because of their policy. With Greece, we are extending in research output. Then we are applying for a tender. I don't know if it's gonna go. And we are also doing another very interesting experiment with the University Alliances, in which the idea is to monitor open science in the context of the University Alliance policies. And this is another interesting point of view, because we are trying to follow the COARA principles, in which you cannot do any ranking, right? Even if sometimes the users want to have ranking, but we are avoid that. The idea is that you can monitor by institutions, and also you can maybe help each other, or having a search functionality for the researchers to browse among the expertise inside the university alliances. There are several monitors that we are performing at many levels. It can be regional. We have, for example, we have supported the NARCIS, and in that case it's a network of repositories, so it's focused. But we have several possibilities. So depending on what you like, if you are interested to trial or to have more information, please contact me.
Okay. Any additional question from the audience? No? Okay, so let's thank Giulia again. Thank you. Next speaker is Alessandro Bertozzi, who is going to introduce a talk entitled Boosting Data Interoperability of GoTriple.eu.
Hi everyone, it's a pleasure to be here. It's the last mile, I promise. No, maybe the last 2 miles. I am one of the miles. But okay, today I will briefly discuss about the next things about that concern GoTriple, that maybe you heard already about that during the previous intervention. Today, in particular, my focus is about the data model that the ontology data model that I developed during my master degree. Just for a quick reminder about what is GoTriple. GoTriple is the main outcome of our European project, Triple. Is a multilingual discovery platform. Is a search engine to discover publication, projects, and author and research profiles in the domain of SSH, social science and humanities. At the moment, the database count 19.5 million publications and 25,000 projects and 22 million authors. There are several personalized features inside the platform. In particular, there is the integration of innovative services like Recommender, visualization and discovery system, and annotation tool, Pandit. The platform for the kind of audience that is across all of Europe support different language, at the moment 10 languages. And in another project we are experiencing some stuff with the artificial intelligence, in particular the integration of a chatbot inside the platform. Today we will concentrate on an ongoing project. There are several projects ongoing that concern the GoTriple platform, but in particular today we are concentrating on the Atrium project. The Atrium project involves several partners, 29, is a project of a EU project of 48 months. The goal of Atrium is to bridge leading research infrastructure in art and humanities, archaeology, languages, and open scholarly communication, the social sciences, and the humanities. In this project, we are trying to deal with several points, as you can see in the slide. The idea is to develop a new connector to new data source, like, for example, Mark 21, refining the data model, keyword reconciliation, also using AI tools, an improvement of API, and complete enriching the triple ontology, based also on the extension of the data model. Today, we will concentrate on the last point. Maybe it's the boring one, but okay. Is the stuff that I deal with. First of all, let's briefly introduce what is the data model. The data model of GoTriple platform is based on three main entities: the documents, the authors, and the projects. In this case, we want, inside the Atrium project, to extend the data model for support different content types, in particular dataset, semantic artifacts, and software and multimedia. What about the ontology? Because the ontology is strange, maybe, because first was created data model that is a data model that is based on Elasticsearch. Then came the ontology. First draft of the ontology was based on schema.org, and the idea was to not only find a way to represent the data model inside Elasticsearch, but another idea was to create a list of controlled vocabulary for making it available to the audience and the possible researchers that interact with the platform. In particular, about the disciplines, the idea was to formalize the connection with external vocabularies, like, for example, Morse disciplines. The idea was to develop in a standard way, in this case, a SCOS-based linked data source. And the idea was to also provide inside the platform at the API level a system that supports linked open data, like, for example, the standard JSON LD. And in particular, the ontology must provide a support to another important feature for GoTriple, that is multilinguality. How we develop the ontology? During my master's degree, I developed the ontology reusing the methodology SAMOD developed by Silvio Peroni. This was a very use case because for our side it was quite easy to pass from a data model to an ontology system, in particular creating some system based on the interaction, and during the construction of this interaction, we produce a comprehensive documentation in a way that not only we can expose our final data model, but we can also document all the steps that we defined for creating the ontology. Okay, the ontology in Atrium. The idea of the ontology extension in Atrium goes in two directions. The first one is to integrating other two entities that are already there, but this extension is inside the Atrium project, that are in particular project and profile. And the other direction that is an ongoing process is the alignment with the widely used ontology inside the SSH domain. In particular, CDOC CRM and Scrl, and the other interoperability framework, SKJIF. Okay, now the last two slides, I promise, but I dive in just in a first draft, a possible alignment with the CDOC CRM Scrl. The idea, the need to satisfy is to improving the compatibility with the standard ontology of the SSH domain. CDOC CRM is one of those, and also Scrl, that is an extension of CDOC CRM. The difficulty that we meet during a first approach to this alignment are the differences between the two philosophies. Because CDOC CRM is an event ontology that is different from our ontology that is an object ontology. But the idea, the philosophical idea behind CDOC CRM is a wide comprehensive of the SSH domain. Our idea is to create an ontology that is more near to the data that we import inside our platform. But a possible alignment, as you can see from the slide, is to align our main entities, like, for example, document, with the A31 document class, and the project with the A7 activity class. For Scrl, we can state that we can align with other classes that we define inside that are defined inside the ontology, in particular for the other class that we added during this project, that is publication, dataset, and multimedia. But still, some mappings in this case remain maybe too generic from this kind of from the point of view of the extension of the classes itself. Last thing is about the alignment with SKJIF. The idea is to enhance interoperability with existing graph. And here there is a possible alignment with the module that are specified inside the SKJIF. The idea is to align the profile module, our profile module, with the agent module specified inside the interoperability framework. The project module to align with the grant module, partially, because we, in this case, is described the grant module, but we have projects that don't have a direct connection with the grant. The other part is the publication and dataset and software that can be a possible connection with the classes that are specified inside the standard, that is scholarly work, dataset, and software. At the moment, we don't have a perfect mapping for the multimedia and projects that are other entities inside our database. Okay, just for concluding my discussion, what are the future perspectives with the other project, but in particular with Atrium? The idea is to complete in Go triple data model and it is corresponding ontology. The other fact that may be solved with the thing say in a previous discussion, achieve application level interoperability from data. not just form alignment for vocabulary. So we want something that allow the user not just to read in a documentation and on his own find a way to create this kind of interoperability, but we want something that at application level, for example at API level, can allow the user to interact with this kind of alignment. Other thing is about the alignment with SKIF interoperability framework is important for the Graphia project, because the idea is to allow the possibility to extract this data for contributing to the creation of the SSH knowledge graph. And the last point is, in a way, connected to the second point. The idea is not to create just a documentation, but also an application level, but the documentation stay as a good way to interpret and understand what is our choice about the data management inside the platform. So maybe a possible improvement is to improve the transparency of the documentation and the narration about the choice taken during the developing process of the ontology. Thank you for your attention.
Question from the audience for Alessandro.
About SKGIF, you were mentioning that multimedia cannot be mapped. There are a couple of objects that that is a bit difficult to.
At the moment, is a first draft of a first approach.
So we have this other research product, and I at this moment, I mean, off the top of my head, I can't remember what is the ontological class. It's pulling. It's a Fabio work, generic one. So that could be a possible way out for aligning that. And then about project, there is an extensive ongoing discussion that comes in waves about that. Because we, again, like in SKGIF, we model grants, because unfunded projects, we know that they exist out there, but most of the SKGs, most of the initiatives and data models that we were landscaping at the beginning, they do have grant money attached. So we made this pragmatic choice to model grants. But of course, like, there are purists in the working group that would like to have this kind of distinction to be in place, because it makes sense. It totally makes sense. I'm not sure what is the percentage of use cases it covers, but I think after June we are going to resume this discussion once for all, and possibly adapt that to this use case as well. So, you know, like, stay tuned. It could be it could be the case that everything solves by its own.
Yeah, no, it's just a suggestion. So first try for alignment, but yeah, it's just a first try. But we are totally open for also integrated, modify our way to approach the alignment, because that's the idea. So from a certain point of view.
Other questions? I have a very quick one to ask. So first of all, you have developed this ontology. I was wondering if you are already modeling data in your system, in GoTriple, according to the ontology, or if so far it's just a way for exposing data through API. So what is the current status of implementation?
At the moment, the idea and the original idea about the ontology is to provide a layer, a different layer, a semantic layer, for interacting with the database that is an Elasticsearch database. And at the moment is the same thing. So we put the data inside Elasticsearch, and it's quite difficult to move from this kind of system to another, for example, a triple store. So for this reason, maybe will remain a layer, okay, inside the framework that we use on the backend, that is API platform. So you can just, with the content negotiation, decide what kind of data, content type that you receive back just for the request. So in this sense, I think that we remain with this kind of stuff, but the idea for the future perspectives is always to find a way to expand the data model layer and then decide to expand the data model, also the semantic data layer, and then provide documentation and about the possible alignment with that kind of semantic data layer.
Very quickly, actually, for the new classes that we're mapping, actually, it's ontology first. It's ontology and data sources, data model first. So actually, we still use schema.org for, let's say, documentation, etc. But basically, we are trying to say, okay, for example, for semantic artifacts, which are the ontologies that we might use? Question number one. Question number two, where are we going to take data and which is the data model that they use? So right now, actually, even if what Alessandra says remains correct, that is at the end of the day for us, it's especially for exposing our data. But right now we are, ontology guided as well.
Okay, there are no more questions from the audience. So Alessandro, thank you for your talk. And we are approaching the end. This is the last talk, so I will ask Sebastiano Giacomini to come here. And the talk is entitled Fair Digital Humanities Scholarly Metadata, the Atlas Project.
Perfect. So good evening, everyone. Thank you so much for the opportunity to be here. It's a real pleasure for me to introduce the Atlas Project today, an initiative supported by a broad working team made up of 3 main institutions: the University of Bologna, Ca' University of Venice, and the National Research Council. So today I'd like to give you an overview of the Atlas project, focusing on the methodologies behind the creation of a knowledge graph that maps international scholarly research on Italian digital cultural heritage. So the main goal of Atlas is to bridge the gap between physical cultural heritage and all the related digital humanities research products. As we know, cultural heritage consists of analog objects such as artworks and manuscripts that inform the creation of digital humanities resources like digital scholarly editions or text collections. However, while separate catalogs exist for both physical heritage artifacts and digital humanities research products, there's currently no integrated system that allows users to explore both physical cultural heritage and its digital interpretations in a unified environment. In other words, no system enables users to discover all digital humanities research products related to a specific analog object. And Atlas bridges these divides by linking cultural artifacts to the digital research they generate, highlighting connections, relationships that are often hidden, and making digital humanities research products more meaningful and discoverable. So, of course, many initiatives already aim to describe digital objects and digital research products, but existing models fail to capture the granularity and complexity of the digital humanities landscape. In addition, Italian digital humanities outputs remain fragmented, as there's currently no comprehensive and reusable linked open data catalog aimed at enhancing Italian cultural heritage through semantic web technologies. So, based on these challenges, here is a set of objectives that the Atlas project aims to achieve. So first, Atlas aims to map international scholarly research, international digital humanities research on Italian digital cultural heritage through linked open data, connecting people, projects, and practices to the sources they study. Then we promote fair principles and long-term access by providing an ontology, a search portal, and a white book. And by developing an ontology, a shared ontology, we also aim to support the interoperability and the reuse of both models and data. Finally, Atlas wants to capture the diverse perspectives behind the creation of diverse different types of digital humanities research products. So the workflow supporting the realization of these objectives began with the analysis of a set of selected pilot research products to identify their key features. We then mapped their metadata and aligned this information with existing ontologies, creating new components where necessary. The resulting Atlas ontology was then integrated within an application, the Atlas web application, which supports both data entry and visualization of a catalog of digital humanities research products on Italian digital cultural heritage. So in particular, to develop our ontology, we addressed the following research questions. The first one, what types of digital humanities research products can be identified? The second one, how can we represent their distinctive features? And finally, which metadata are essential to support to ensure their preservation, findability, and reuse? So I will not go into detail here, but I'd be happy to discuss this further whenever it's possible during the question answering time. So briefly, the main tasks we carried out included the selection and analysis of pilot research products, metadata evaluation and issue detection, the development of fair aligned practices, and finally, recommendations actually, and finally, metadata alignment and refactoring. The refactoring stage in particular was informed by several well-known standards and existing ontologies, actually models, such as RockRate, OpenAIRE, in particular OpenAIRE Graph and the OpenAIRE Application Profile, and the Scientific Knowledge Graphs Interoperability Framework. So the results of these steps coincided with the formalization of the Atlas ontology of a new ontology, whose central focus is represented by research products, of course, and additional classes are made available for the description of research projects, people and organizations, and computer programs and websites that provide access and support for digital humanities research outcomes. At the core of the Atlas ontology, we have a backbone based on properties and types from schema.org for broad interoperability, and this foundation is enriched with terms from the Fabio ontology, which brings in the Ferber model, DC terms, the friend of a friend vocabulary, but also domain-specific resources like the software ontology or the Venn vocabulary. At the same time, the ontology has also been designed to integrate with some of the most relevant and well-known taxonomies and authority records, including domain-specific resources such as the Tadira taxonomy of digital research activities in the humanities and the NOT taxonomy of digital humanities objects, which are both extremely useful for the description of digital humanities practices and methodologies. At the same time, we consider also general purpose resources such as Wikidata, VIA for geonames. So as we said, research products form the core of the Atlas model and are represented as instances of the schema dataset type from schema.org, of course. So this type is broadly defined as collections of packaged data and can cover many different data formats, meaning that this broad definition alone does not fully capture the granularity of the digital humanities research landscape. And that's the reason why the first version of our ontology introduces 5 Atlas subclasses of schema dataset to identify different types of research products. In particular, we considered digital scholarly editions, linked open data, text collections, ontologies, and software. So, of course, by assigning one of these subclasses to a research product, it becomes possible to further describe it through additional properties, for instance, the programming language of a software or of a piece of software, or the type of text included within a text collection. The next version of the Atlas ontology will introduce 2 additional Atlas subclasses, covering for 3D models and language models. However, even with these 7 categories, not all digital humanities research products can be fully represented. And that's the reason why we are going to introduce a supplementary property that accepts values from taxonomies, from controlled vocabularies such as the NOT taxonomy, the not taxonomy of digital humanities objects, enabling greater flexibility. So users can select terms from controlled vocabularies to better define the nature of a research product when none of the available Atlas subclasses is a perfect fit. So, to validate the Atlas ontology, we adopted an application-based approach, meaning that we built an initial knowledge graph as a proof of concept, and this was done using the Atlas web application, which also provides access to well-available data. And the screenshots you will see in the following slide are taken from the Atlas app itself and offer us some practical examples of how Atlas reaches some of its goals. So, for instance, the analysis of the Codice per l'Avicino digital edition shows us how digital humanities methodology, standards, and practices can be captured. For instance, we can observe the reference to the TEI encoding standard, or the description of both promoted and carried out research activities categorized using the Metadata taxonomy. The analysis of another digital scholarly edition shows how the specificity of a research product type can be captured through dedicated properties and terminology. For instance, we can observe details such as the authors of the edited text or the type of the edited text, but also the type of edition produced. And finally, through a navigable catalog, exploration filters, and data visualization tools, we aim to support to foster the findability of digital research, of digital humanities research on Italian digital cultural heritage. So just a quick mention, in the context of cultural heritage valorization, the Atlas web application provides users with some methods to semi-automatically or automatically extract knowledge from various sources, including static files, full text, API services, and SPARQL endpoints. And to conclude, looking ahead, the next steps of the Atlas project will, of course, include both the expansion of both the Atlas ontology and the Atlas knowledge graph. Then, to further support the findability and dissemination of digital humanities research products on Italian cultural heritage, we aim to create, to develop a dedicated gateway with OpenAIRE Connect. So that's basically everything about the Atlas project. So thank you so much for listening, and thank you so much.
Thank you, Sebastiano. Any question from the audience for Sebastiano?
I have a very naive question.
Okay.
For the, let's say, the paper edition of Divine Comedy.
Yeah.
Okay, it's, of course, there's no copyright of any kind on it. So I imagine you have dozens and dozens of editions that actually exist, not only in different publishers, but also in different versions, the edited one, the redacted one, the one with the original language compared to modern Italian or whatever. So how did you treat this part? Because you said that the database was supposed to link cultural heritage product into their, let's say, physical paper form compared to the ones that exist in the digital space.
Yes, so actually this is a work in progress because, as we said, we are still working on, of course, gathering feedback from the community because we want to involve the community in the creation of a good knowledge graph and a good semantic model. So we have a set of properties for the description of the sources of digital scholarly editions, and those properties usually accept values from some resources, controlled resources, for instance VIAF, which provides references to specific physical version of a book. For instance, in this case, the Divine Comedy is one of the most complex cases we could study. So, to be completely honest, we still haven't tackled such case because, of course, it will be extremely complex. For the moment, we are working on some cases which we can somehow control because the members of the Atlas project are also members of the creation, members of the Atlas project took part in the creation of those resources, of those digital resources, so they can also provide some insights also to the references using also control resources and authority records, yes, basically. And that's also the reason why we introduced the Ferber model, because we wanted to create a connection between the work and the expression, so we wanted to work on this level.
Thank you for your presentation. So I have a quick question. Are you planning to have, let's say, a bulk ingestion of a kind of a CSV data set, something like that?
Yes, and that's one of the reasons we are going to, first of all, to introduce an additional property to classify, to better specify the nature of those research products which cannot be classified using Atlas subclasses. In the case of a CSV dataset, the easiest option will be to classify this CSV dataset as an example, an instance of the schema dataset type, which is the main one we have decided to include in our ontology. And then we can better refine the function, the goal of this CSV dataset using additional properties, including the one which accepts terms from control vocabularies. So we can better define the nature of this kind of output. Yeah.
Any other question for Sebastiano? Okay. Thank you. Thank you for your talk.